So now when we use Bayesian theory, we take into consideration the features when we take the decision. So we have to calculate the prior or posterior probability, and if the posterior probability for specific class is greater than the other class, then we take the decision to select that class that have greater probability for the posterior probability. So the probability of error or risk, we name it the risk now, probability of error given feature X, it's a probability of selecting W1 if we decide W2. Same like the original one, yes? When you select W1, it's the probability of W2. When we select W2, it's the probability of W1, yes? So if we decide W, then probability of error giving this feature, it's probability of W1 given X. If we decide W1, then probability of error, it's probability of W2 given X. Okay, so this one we can write it like this. Probability of error, it's the minimum between, why it's the minimum? Because we use the maximum to select the class, yes? So the minimum one, it's the probability of error. The maximum one give us a class that we will classify it. Okay, so we can make it more general. This means more than one feature. Okay. So what we could change with Bayesian theory to use it in the classification. Usually we have more than one feature, not only X, not only one feature. Usually we have more than two classes, not only state 1 or W1, W2. We could have more than one classes. We will see all this when we have more features, when we have more classes, we will see it later. Also another issue, the action, doing some action, okay, like rejection of the class, a specific class, we will take it. Also, the calculating the risk. All this could be used to make the rule more general. We will take it, all this. Okay. So about the state C or the classes C, we could have more than two category or two classes. We could have W1, W2 until W C. See here number of states or number of classes. Okay. And here we will take the action into consideration. We will name the action here as alpha. So we could have more than one action, alpha 1, alpha 2, until alpha A. A means number of what? Of possible actions. So if possible actions, it's a 3, then A equal 3, then we have alpha 1, alpha 2, alpha 3. What is the alpha? Specific actions that we will take. Select the class 1, reject the class 1, and so on. The actions. Lambda here, it's the error, yes, the loss. When we select a specific class. So lambda of alpha I wj, for example, lambda of alpha 1 w2. What's this mean? Selecting action 1 when we have a class 2. Okay, this one, it's the loose. Okay, what it's meaning? It's meaning if you select, for example, the fish, or if you put in the box the fish and consider it salmon, but it was not salmon, what's the loose here? So how to calculate it? Who guess how to calculate it? It's given to you. It's from the experience. We know that if we select, for example, in the box sea bass, but it should be salmon, then, for example, we will lose by making the customer angry. We will lose for the return for some money and so on. Yes, so we know it from our experience. So this lambda, we don't need from you to calculate it. It will given to you that we have this loss when we take this action with this class. Okay, and now we speak about X here as a feature vector. This means we could have X1, X2, X3, and so on. Every one of this X, it's a feature. So I think we already taught this one. Okay. But here, the different. If you look to the previous one, we said X like this. Okay, this was feature vector. That one, that X, it was only feature, one feature. This one feature vector. Okay, and here the second different, that PX, it's from 1 to C. What C? Number of classes, number of state, or number of classes. Okay, so it's become general now. We have feature vector, we have number of classes. Okay, so what's the risk now? When we take into consideration more than one feature, this vector of feature, and we take the action here, what's this mean? Lose for taking a specific wrong action, okay, with a specific class. So class, for example, salmon fish, and it was wrong action. What's the calculation? Okay, it's given to you because it's from the experience, like the prior probability. Yes, prior probability from where we take it. For example, probability of a class W1. We don't calculate it. It's depend on the experience, for example, experience of fisherman and so on. Okay, so to calculate the risk here, or the cost, or the conditional risk of taking a specific action for this features, it's a summation from 1 to C. What's C? Number of classes. For the loss, lambda means the loss here. Okay, alpha with W, specific alpha with specific W. So summation, we will take all the different what? Classes. Specific alpha with all of the different classes. How to write it? This one, this general, yes? For example, if we take action alpha 1. So how to calculate the risk if we take action alpha 1. Alpha 1, select, for example, the fish as salmon. Alpha 2, it selects the fish as sea bass. So how to calculate the risk of alpha 1? It's like this, risk of, I write this one for alpha 1, this rule, this one. Okay, so the risk of alpha 1 given some feature, this vector of feature equals the summation of, for example, if we have two classes, so the summation of J equal 1 and 2. C here equal 2 because we have two classes. If we have 5 classes, so then it's become 5. Lambda alpha 1 with W what? Sorry, with W, not 1, WJ, because we take J from here. It could be 1, it could be 2. We take the summation, multiply by W of WJX. We can calculate this one? Yes. How to calculate it? First of all, lambda, it's given to you. So how many lambda here we have? Because we have two classes, so we have 2 lambda, which is lambda of alpha 1 with W1 and lambda of alpha 1. From where you get it? So let me write it in another way. And in another color. Okay, then this one equal. Now I will calculate this one, the summation. It's equal lambda alpha 1. Why alpha 1? Because we take the risk of alpha 1, yes? Given W1 multiplied by probability of W1 given X plus, now we take the second summation, which is lambda of alpha 1. It's still alpha 1. I, it's different than J, the summation only for the J. I, we take it as 1 here because we take alpha 1. I, it's related to number of alpha, which alpha. Okay, or lose that we will calculate. So alpha 1 given W2 now, because we just here, and then we take J as 2. Multiplied by, I write it here, probability of W2 given X. Okay, what we know, what we don't know from this one. From this one, what values we know, what values we don't know. Lambda, we know it. We said it's given to you because it's probability of the loss. Okay, when you use or when you select a specific class. Okay, probability of W1 with X. What's this one? It's the posterior probability, yes? A class given specific features. We will use what? We will use this rule to calculate it. Specific class given some feature, and we show this one by numbers here, I think. In one examples here, I mentioned it, okay? How to calculate it. Okay, so this one, we have to calculate it. And this one given to you, and this one, probability of W2 given X, also you need to calculate it from this formula. So like this, we can calculate what? The conditional risk. Okay, this another way for the risk using the differential equation. I don't care about it too much. Okay, so let's take this example for the risk. We have here 2 alpha. What is the alpha? The action, yes? So action 1, it's deciding that it's W1, it's C pass, for example. Action 2, it's deciding it's what? A salmon, for example, in our example. So action 1 is deciding that this item is W2. And we have how many loops here? 4. Why 4? No, let's try to understand it. We have 2 actions and 2 categories. So taking action 1 with category 1, taking action 1 with category 2, taking action 2 with category 1, taking action 2 with category 2. So 4 different values for the losses. Make it general. So general, it's I what? I means number of actions. J means number of classes. Okay, so we have 2 actions with 2 classes. So how many alpha lambda we have? We have lambda, 4 lambda. Lambda when we have action 1 with category 1, lambda when we have action 1 with category 2, lambda when we have action 2 with category 1, lambda when we have action 2 with category 2. This action I could be 1, could be 2. And the category could be 1, could be 2, because we have 2 categories. Okay, so how many lose? How many lambda? We will have, if we have 2 actions with the 3 category, 6, and so on. Okay? So the risk, how many risks we have? Risk for each action. Okay. The risk of, wow, I forget to bring my cable, my charging cable. I don't know if anyone have laptop like this. If it's, I think this need a high ampere. Yes. Yes. I don't think it's okay. Let's continue. Let's continue until it's closed. You have the slides, but I think let's okay. This performance. Let's try to battery saver on. Okay. This one take 10% of the battery. So let's close it. This one take 10%. Microsoft Team, I cannot close it. Okay, let's continue. Hopefully it will lasting for a few minutes. Okay. It's a new battery, so I expect it will last for a few minutes and it will tell us before closing, hopefully. So the risk of selecting this action for a specific feature and the risk of selecting this action for a specific feature. We take the rule here, yes? It's the summation. The summation from 1 to the category for lambda, action with category, and probability of category with feature. Not save the video.